Kia ora Catherine, and tēnā koutou, tēnā tātou katoa. Yes, in fact I still live in the Hallsville, Taitapu area. So I grew up there, and Catherine was talking about the swimming sites like Coes Ford and in the Upper Cell, and it's the same for me. I grew up swimming at those places as well. So I think most of us have got a stake in this, and that's why we're so interested in it, and it's great to see such a big audience and an interested audience this evening. What I want to talk about is, show you a bit of data, show you where Canterbury measures up in these swimmability stakes. And you'll notice that all through this presentation I put quotation marks around swimmability, because personally I think it's a terrible term. It narrows just in on the swimming, whereas as John has outlined and Doug will later on, there's a lot more to recreational use of rivers than just swimming. So, swimming gets the sort of the headline, I guess, but it is a lot more. So I'm going to concentrate mostly on the pathogen side and the E. coli measures of those pathogens, and a little bit on the cyanobacteria, and I won't talk too much about some of the clarity and depth things, which are important. It's just I've got a limited time, and I'll concentrate on particularly the E. coli. And the trouble is, when I'm asked how do I report and say how do we measure up, that for better or worse, and to a large extent for worse, because it makes it very complicated, there are 3 different ways of grading E. coli for swimmability. So it does make it complicated, and I'm going to present a range of these, and I'll try and explain the differences, because there are reasons for the differences. There's subtle reasons, but it does make it slightly complicated, and I'll just try and talk you through those. The first one is the 2003 Ministry for the Environment, Ministry of the Health guidelines around contact recreation in fresh waters. Or in fact, it's not just fresh waters, it also includes coastal environment as well. And in terms of fresh water, that is limited to the swimming season only, so only over the summer. So the data that I'm showing in this way are from our weekly monitoring, and by our, I'm talking about Environment Canterbury, our weekly monitoring. And then the grading is done with 5 years of data, and it also includes a sanitary inspection at the site. And a sanitary inspection is somebody goes out and they look for things like, are there toilets nearby that perhaps don't have proper treatment? Is there open access for stock? Those sorts of things. So it's a bit of a risk assessment as well as brought into the grading system. So that's the 2003 guidelines. The second classification that I'll just briefly show you, and I won't go into too much, is the Land, Air, Water Aotearoa site, LAWA, as it's often referred to. I've got the website link later on, you can, if you want to write it down. And in this classification, it's quite similar to the first one. It's the swimming season only, so it's that summer weekly monitoring data. In this case, the classification is based on 3 years of monitoring data, and that's to do with the 2014 National Policy Statement, which was based around 3 years of data. So it's just a subtle difference there are. And the categories that are used are more risk-based than the 2003 guidelines, and I'll show you those. And then the latest kid on the block is the 2017 National Policy Statement for Freshwater that John has talked about. And in this case, the classification is, and this is really important to realise, is based on all year round data. And in fact, the data that I'll be showing you is monthly data all year round, not just during the swimming season. And the classification is based on 5 years of monitoring, and really it's aimed at E. coli as a general water quality indicator and some of the long-term change, rather than particularly the swimmability aspect of it. But it gets tied in together, and it does get a little bit confusing. So if I could kind of move on reasonably quickly. Fortunately the sun's going down, and hopefully you can see some of this. This is a direct screen grab from the Environment Canterbury website under swimming water quality. And this is using those MFE MOH guidelines that I talked about, 2003. The data are from the summer before last. We haven't, our data for last summer are just being worked up, and they're just provisional at the moment, so I'm not showing those. They will be on the website very soon, certainly before the swimming season starts. And you can see that the grading system, which again, if you remember, was based on the summer only, it goes from a very good, good, fair, poor, very poor. And under this classification system, the bottom two categories are considered non-swimmable or unswimmable. So the top three are considered swimmable. And that's to do with the risk of Campylobacter infection. Now, and I should just add that the 2003 guidelines, some of the science behind that was done in the late 90s and early 2000s, and it's just about to be revised. There's a project just about to start. Next week, in fact, it's about to start, looking at some of these relationships again. So this is the classification for sites. It's also got, in this case, you can see it's got marine sites, the coastal as well, so that's sort of cluttering it up a little bit. But you can see what it shows for Canterbury. And if we just zoom in, and I'll take Coes Ford as an example because it's been in the media spotlight this summer, and quite rightly that it should be as well. So if you zoom in and you look, the Coes Ford is showing as poor, so that's the classification over 5 years of data, and it comes up as 4. And the technical detail, it's a 95th percentile, but I won't go into the detail of that. If you click on that where it says show sampling history, this is what you see off our website, which is last year's monitoring data. In that case, it's 2016-17 E. coli from the summer season. And what you can see is that there were 2 times that it was over the 550 trigger level. So there were 2 times that it breached and that it was considered unswimmable in the surveillance monitoring. And it's really important to get this distinction between surveillance, which is what these data are, and the grading, which is where it shows it as poor. So this is a way of looking at the latest data. You can see what it was within the last week. If we pull it all together and start looking at using those guidelines, using that grading system for our river sites, rivers and lakes, and there are 50 of these, and I should have said at the start that our monitoring program for this is based on where we know people go and swim. So it's a targeted monitoring. It's not just a random thing of every lake and river in Canterbury. It chooses sites like Coes Ford, Ashley Gorge, other sites where we know people go and swim, and in the lakes as well as in the coastal area, but I'm just showing you freshwater. So this is the percentage of the sites where people swim, and there are these 50 lake and river sites, and if you put that into the non-swimmable, then what you're seeing is 24% of them are in the poor or very poor, which are considered unswimmable. So 24% are in that, and quick bit of maths there leaves me at 76, I believe, which are considered swimmable under that grading system. And you can see that quite a few of those are in fair and good, and less are in the very good. So that's a sort of a snapshot. If we look at it with time, this is a little bit complicated, but if you just concentrate on the green bar for a start, I'll just explain it. The blue is rivers, the light blue is lakes, and these are percentages of our samples, and the green is those combined. It's all of them together. So if you just sort of concentrate on the green bar, you can see this is telling us of our monitoring sites, of which there are 50, it shows it with time, and you can see that there was this decline through from about 2012, and then in the last couple of years it has started to improve again, and we're starting to see better results. Now that goes to 2015-16. As I said, our provisional results haven't quite been ratified yet, but they do show a further improvement, and it moves from 72%, which is shown there, to 76% of them are considered swimmable. So that's another 2 sites I think have come through. Anyway, we've got more sites that have come through as swimmable. So that's using our contact recreation data. This is the Lawa site, and you can see so that's land, air, water, Aotearoa. And this is a site for all of New Zealand. It takes the Environment Canterbury data and it puts it and it displays it, and you can see the whole of the country, so it doesn't matter where you are, you can have a look at what the swimming water quality is like. And in this case, what's being shown, the dots on here, is the grading. So again, this is the swimming water quality at the swimming sites, so where we know people swim. In this case, it's 3 years of data, and it's put into this. You can see it goes from well, you might not be able to see, but it goes from very low risk, which is the green, down to where it says caution, which in this case it's a 4-point scale, and the bottom black one is just no data. So in this case, you can see the different sites. During the swimming season, when there are live data, so we haven't started monitoring yet, we don't start until mid-November, then what you'll see is instead of the grading, you'll actually see the surveillance monitoring, which is the latest one for each site. And that's that little thumb up, thumb like that, or thumb down. So the thumb up is that the E. coli levels are less than 260. The thumb somewhere in between is the warning, saying it's between 260 and there's a bit of confusion between 540 and 550, and I just can't remember which one this is. But it's essentially saying that it's it's not great, but it's still acceptable. And then the thumb down is when it's above 550. So that gives a quick way of looking at sites what the latest data are showing. And if you click on the site, you can then see over a period of time what the data is showing, or what it's been like this summer. And if we just look at last summer, then in the freshwater environment there were 760 samples taken. So that's over this period of however many weeks it is, 12, no, must be more than that, weeks, 12, 15 weeks, weekly samples at these sites around Canterbury. 760 samples, 667 of them were acceptable, got the thumbs up, were less than 260, 42 were in that alert level, and 51 were unacceptable. And the 51 were actually dominated by 2 sites in particular. That was Lyle Creek in Kaikoura, and it's never had great water quality, but it certainly wasn't helped by broken infrastructure after the earthquake, and the Avon at Kerrs Reach, which were, had consistently bad water quality. So they've tended to dominate those, but there were other ones as well around the base. So for instance, if you remember, I showed Coes Ford, and there were 2 times during the summer when it breached the acceptable level. So that just gives you a kind of a way of looking at the data. You can see, it gives you something you can go and see what the latest are, as well as some of the grading. If we then move on to the new kid on the block, the National Policy Statement for Freshwater Management 2017, that, as John said, I can't remember if it was August or September, that it was ratified. And if we look at what are now all year round sites, this is not our targeted swimming sites, these are sites across the region, and it's all year round data. And in fact, when I say it's across the region, it's actually slightly biased towards the lowland areas, because we monitor those sites because we know there are problems there. So we're doing the monitoring because we want to see how they're responding and how the changes might be happening with time. So if we do that and we apply the NPS-FM methodology, which was that multicoloured table that John put up with the 4 different columns, and you come up with a grading system, then what we end up with is something like this. And bearing in mind that the left-hand side, the colours are a bit funny, but the red and the orange are considered unswimmable, what you're seeing of those samples, those sites, 49% are considered unswimmable, so 51% are swimmable. And of the swimmable, there is a majority in this, more of them are in the A grade, but there is this really large amount of poor quality, which are considered unswimmable. And just sort of re-emphasising that monitoring network is dominated by lowland sites, and therefore it's not really surprising when we see this. But I'll come to a conclusion around that later on. Here's another way of looking at it, just to confuse you even more. This is what the monitoring target. So Catherine mentioned the National Policy Statement sets a target of 90% swimmable by 2040, and this is based on modelled data. So in this case, it's saying we're looking at the whole region, not just where we monitor, because we can't monitor everywhere. So in this case, it's actually trying to model across the whole of the region. And if you can see the colours on there, the blue is excellent and the red is poor, and it shows what we know, and it makes sense that the lowland rivers are the ones that are really struggling. They're the ones that have got poor water quality, in this case from E. coli. So it confirms what we know. The model itself is based around the data. It's trained on data, so it's not just completely hypothetical. But equally, you can see that it is, most of the blue is in the mountains and in the foothills. And if we look at the grading system based on this model, you can see that there's a 63% of these river reaches are in the excellent category. So this is, most of those, a lot of those are up in the mountains and in the foothills, but they do dominate a lot of Canterbury. And then if we just you might not be able to read it, but in the Canterbury region, as it stands right now, 86% of the rivers have excellent, good or fair, so are considered swimmable, as measured under this system. So we're at 86%, and the targets are 80% swimmable by 2030, this is national targets, and 90% by 2040. Now, that doesn't mean we can rest on our laurels and go, fantastic, we'll wait till 2040 and then we can up it a little bit. We've actually got targets, and these are being worked through at the moment, to increase across all of those categories, to get more towards the left-hand side of those categories, and to get well above 80 and then 90%. And that's partly for a national target, and also just because there is a public expectation, quite rightly, that things will be improving. So that's kind of another way of looking at it. I'll just briefly talk about toxic cyanobacteria. I won't say too much about it. John has already introduced it, talked a little bit about the benthic cyanobacteria, which are on the stream bed. Formidium, he showed the slide of black that you could see on the stream bed. This is a cobble with the black cyanobacteria growing on it. And then we also have the planktonic, or within the lake, where it's floating in the water column, and in this case it's nodularia that's growing proliferately, both of which are toxic. So what do we know about those? Well, if we take, I'll just say Formidium, it's easier, it's not the only toxic cyanobacteria, but it's the main one that we see. It is completely natural, it's a native species to New Zealand, but we are seeing an increase in our rivers. So it's one of these things that's quite hard to get a handle on what's actually driving the change. So we are seeing an increase in it. It is that nutrients are part of the story. John was talking also about flows as part of the story, that less flushing flows coming through, which could be climate change. It can also be linked into some water abstraction practices. There's a lot of research being done right now on what is really driving that change, because if we don't know what's really driving this increase, it's hard to manage for it. And this is one of our problems. It can be toxic, but it isn't always toxic, and this is one of our dilemmas. The warnings that you see that are put in place is when the cover across a river is greater than 50%, so on the stream bed, greater than 50%, and you've got detaching mats. And the detaching is really important because that's actually where the dogs get at it. It tends to get washed ashore, you get a mat, and the dogs go in and they sort of snuffle around and try and eat it, and it can be toxic, but it's not necessarily toxic. So when they're detaching, we put the warnings out. We don't actually know if it's toxic or not, we're just being precautionary around that. And the other thing that always worries me about it, I was talking to John earlier, there's dogs, but also, little kids as well, if they're sitting around on the edge of a stream and they like to pick things up and put it in their mouth. And it can be highly, highly toxic. So it is a real concern. In the 2016-17, so last summer, we had 9 rivers that were affected by Phimidium. But there was actually 22 swimming sites. So some rivers like the Ōpihi in South Canterbury had 5 of our monitoring sites on it where people swim that were affected by Phimidium. So, it really is quite a significant problem. In terms of the lakes, it's a problem particularly in lowland lakes with high nutrient concentrations. And it's to do with the balance of algae, which are, the algae aren't toxic, and then cyanobacteria, which are. And they can change, that balance can change in a really short time, and it's often to do with some of the dynamics going on in the lake to do with deoxygenation and release of phosphorus, and some of these things can drive sudden changes of and cyanobacteria in the lakes. In 2016-17, last summer, we had 4 lakes that were affected by toxic cyanobacteria, Lake Forsyth, Wairua, Waihora, Te Waihora, Lake Ellesmere, Pegasus Lake, and Rotorua in the Kaikoura district, a little lake that you don't normally see, but it's just off the road, all affected by the toxic cyanobacteria. Yep. So the question I've been asked is how do they measure up? Well, cyanobacteria appears to be getting worse. Our monitoring would suggest, which shows that it does. We're seeing more of it, and that's a real concern. But it's really hard to understand exactly what the drivers are. It's not just a simple nutrient, this nutrient, that nutrient. As John said, it can get phosphorus out of sediment. There's all sorts of complicating factors in there. If we weigh up, I'll put these 3 up just so that it kind of shows it. If we weigh up the 3 different ways of grading, then what we'd see is that under the MFE guidelines, of our swimming sites over the summer only, 76% of them are swimmable. If we look at the wider monitoring sites across the region, but remember these are targeted for the lowland areas particularly, it drops and we see 51% of the monitoring sites are swimmable. If we look at the model for the whole region, then it's showing that 86% of our rivers are swimmable. Now that lower figure is not altogether surprising because, as I say, it is targeted. We do know that we are targeting a lot of these areas where there are issues. And the higher figure, again, is not surprising because it includes our alpine, a lot of our alpine areas. But, there are whole things about how often do you go swimming in the Hooker River or the Tasman River, which are included as swimmable. So, these are different ways of looking at it. They've all got their value. But I guess and then just quickly I'd say that when we look at the trends in the water quality around particularly swimming parameters, we are seeing improvements, and I'll just quickly talk about it as I finish up. So the real question that I like to think about is, is it good enough? So I put up those 3 figures, and the question is that good enough? And the simple answer is most definitely not. It's absolutely not considered good enough, and quite rightly not considered good enough. And that's why there's a really large focus within Canterbury of zone committees, landholders, and Environment Canterbury on improving the water quality. That's what we are working really hard on. And Melissa will talk a little bit about what some of those are. And we are seeing some improvement. So if you go onto the LAWA website, and if you look at Canterbury for water quality, it gives you the overall trends. And what you'll see is improvements in E. coli, phosphorus, clarity, and ammonia. So this is trend analysis done over 10 years of data. And those are classic responses to keeping stock out of waterways. So, if you see ammonia improving, clarity improving, E. coli and phosphorus, which is often attached to sediment, then that's a sign that things are starting to improve because we're starting to see these things come through. But it does take time. We won't, it's not something that's immediate, but we are seeing improvements. So I guess I feel we're heading in the right direction. It's the only slide I could find to show this. And the excellence, I don't know if it's just ahead, but it certainly is ahead, and we're heading that way. And it's so I feel quite positive that we are heading the right way, but certainly the question, is it good enough, is most definitely not. Kia ora.